All right, so in tonight's revision session, we're going to begin by looking at this question that involves some area and volume. All right, so the company makes cereal boxes in the shape of a right prism. Each large box has dimensions of 25 centimeters by 8 centimeters by 36 centimeters. We are tasked with calculating the volume in cubic centimeters of one large cereal box. Right, so we want to calculate the volume. Now, this is a cuboid. So the volume here, and generally the volume of any shape would usually be the area by height or length in this case. So we're looking at basically 25 centimeters multiplied by 8 centimeters multiplied by 36 centimeters. That's going to give us the volume of this right shape prism. Let me check that on the calculator. See me. Should get 7,200. Just give me a thumbs up if you got that. 7,200 centimeters cube. Perfect. So you finish with the volume in cubic centimeters of one large cereal box. Calculate the total surface area of one large cereal box. So basically, we're calculating the area of each of the faces of the box. Right? Now, there are two. This rectangular face to the front here is 25 centimeters by 36 centimeters. And there's two. There's one to the front and there's one to the back. So the surface area is going to be made up of that first face is going to be 25 by 36, and we do that twice. Plus, we have this side here, right, which is 36 by 8. And there are two of those as well. You write 8 by 36. And then we have the top part here. This and this, which is 28 by 25 or 25 by 8. And that's going to give us the total surface area. So we have 1, 2, 3, 4, 5, 6 faces in all. Right? 2, 4, 6, 6 faces. So let's check that. Check that on my calculator. See me. Let me know what you got.
I got 2,728.
2,728. I have 2,776. 25 by 36 plus 8 by 36 2. 25 by 8. 2,776.
Yeah, I get out.
2,776, and we're going at centimeters squared for this one, right? Because our surface area. Yeah? So that's A, that's B. Everybody okay with that so far? Now part C. The cereal from one large box can exactly fill 6 smaller boxes, each of equal volume. Right? Calculate the volume of one of the small cereal box. So this large box that they have here, a visual representation would help. I want you to picture some smaller boxes going inside of here. All right? So you want to picture some smaller boxes going inside of it. They say that this large cereal box here can exactly fill 6 small boxes, each of equal volume. calculate the volume of one small box. So when you pour out of the cereal box, this one large box, it can fill 6 smaller boxes of equal volume. So the volume of one small box will be our total volume divided by 6. And that's 7,200 divided by 6. So that's a total of 1,200 centimeters cubed. This is what the volume of one small box will be. Follow? Everybody okay with that? Right. If the height of a small box is 20 centimeters, list 2 different pairs of values which the company can use for the length and width of a small box. So, essentially, what they're saying here is that, let's pretend this is the smaller box, right? If the height is 20 centimeters, what other values could we put here that will give us a total of 1,200 centimeters cubed? And this could vary. You could choose 2 different pairs of values. 2 different pairs of values, pairs, which could give us the same volume. So let's do it like this. 20 by something could give us 1,200. Or 20 by something could give us 1,200. What you want to use? Let's keep it simple. If we do 10, this box here is 10. 20 by 10 is how much? 200. 200, 1,200 divided by 200 will give me what?
600. Only 6.
Correct. Right? You get 6. So this could be one dimension or pairs of values that you could use. Yeah? What about if I double this up and I use this to be 20? 20 by 20 will give me how much?
400.
400. And to get the other value for here, if I divide the 1,200 by 400, how much would I get?
3.
3. Everybody understand? And you can play around with values like this as well. Right? If we do, for example, 20 by 15, how much is that? You check it, right? And if I divide 1,200 by 300, how much should I get?
4.
4. Everybody understand how it works? Yeah? Lovely. Lovely. All right, so we're going again. Next question. I want to look at a little bit of functions. Two functions are defined as follows. We have f of x is x minus 3. G of x is x squared minus 1. Now, this, don't get confused by the colon and the arrow. It simply means that f of x is x minus 3. And g of x is equal to x squared minus 1. Now, first up, we want to find the value of f of 6. When we work in functions, when we calculate in functions, when we put a 6 inside of this bracket here, what we are doing is we're replacing the x with whatever we put inside of this bracket. Yeah? So when I'm finding f of 6, I'm actually going to put a 6 here minus 3. And I can work this out. 6 take away 3 will give me 3. So if I tell you find f of 10, what would I get?
7.
7. Right? So you will put a 10 here minus 3, we will get 7. And if I say f of minus 1, what will we get?
-2.
So this is what it looked like. -1, -3.
I mean, -4.
-4. That's correct. Very good. Everybody understand that? And it works the same for the g of x as well. If I say find g of 2, I'm going to replace this x here with a 2. And what will I get? 2 squared will give me 4. And 4 take away 1 will give me 3. So everybody understand how that works. It's basically substitution taking place there. Yeah? Good. So going on to the other one, right? Everybody okay with that? Now let's look at f inverse of x. Now, there are a couple steps in order to find the inverse of a function. First, we must list our function. So we would list f of x is equal to x minus 3. Then we will replace this f of x with a y. So we'd say instead y is equal to x minus 3. Next, we're going to interchange our x's and y's. What do I mean? Wherever we had x, y, we're going to put a x. And wherever we had x, we're going to put a y. After we do that, we're going to make y the subject. So if we have x is equal to y minus 3, we want to make y the subject. That means that we want to keep y by itself and move this away from y in simple terms. So we get x plus 3 is equal to y. And this is a very easy example. We've made y the subject. So we're going to then replace the y with f inverse of x. So you could write our answer as f inverse of x is equal to x plus 3. Everybody okay with that? Yeah? Okay. So I'm giving you a simple question to try it for me. If f of x is equal to 5x plus 1, and I ask you to find f inverse of x, can you follow these steps and find f inverse of x? Try it, and then we correct it together. All right, so this is what the solution should look like. Remember, you're replacing the f of x with y. So we get y is equal to 5x plus 1. We interchange in x and y. So wherever we had y, that changed into x. And wherever we had x, that changed into y. The next step is to make y the subject. So I'm moving the 1 across here, it becomes x minus 1. And then I'm moving the 5. I was multiplying here, so now I have to divide on this side. Yeah? So I get x minus 1 over 5. I replace my y with the f inverse of x. And this is my answer. Everybody right to that? Good. So we know how to do a function like f of 6, g of 2. We saw how to do the f inverse. Now let's look at the third question here. Show that f of g of 2 is equal to f of g of negative 2, which is equal to 0. Right? A lot going on there. But we're going to break it up into some simple steps to make it a lot easier. So I'm just going to snip this out from here. Come down on this side. I want to write back my functions. F of x is x minus 3. And g of x was x squared plus 1. X squared minus 1. Good. Now, let's begin first by examining just this little piece here. What is f or g or 2? This is referred to as called a composite function. This is where we are smashing or joining two functions together. Right? Now, when we are doing composite functions, it always is easier to work out the function on the right-hand side first. Find the value of that and then put it into the function on the left. Now, g of 2, we worked that out before, right? I actually gave you guys that to do Up here, this is G of 2. Let's borrow that from up there. So G of 2 is this. The value of G of 2 is 3. And everybody understand how we got that. So if I say that f of G of 2 is the same as f of 3, would I be correct in saying that? I would, right? Because we could work out the value of G of 2. And if G of 2 is 3, we could replace this entire thing here with a 3. And if we find f of 3, we're going to get 3 take away 3, which is 0. Because f of x is x minus 3. If I put a 3 here, then I'm going to get 3 take away 3, which is 0. Everybody okay with that? Anybody not okay with that? Give me a thumbs down. No? Everybody good? All right. Now look at this. G and negative 2. Right. G of, let's just review this quickly. G of 2 is equal to 3. Everybody cool with this, right? We worked out this before. So the value of G of 2 is 3. So instead of writing G of 2 here, which is kind of confusing, it would be safe to say that instead of writing G of 2, we will just put 3, because that is the value of G of 2. G of 2 is 3. Agree with that? So essentially, when you are asked to find f of G of 2, we are really finding f of 3, because G of 2 is 3. Everybody seeing that clearly? Yeah? Right. Now look at this. G of negative 2. G of x is x squared minus 1. G of negative 2 means that wherever the x is, we have to replace that with a negative 2. But the thing about square, if I square a negative number, negative 2 multiplied by negative 2 is going to give me a 4. And 4 take away 1 is still going to give me 3. So G of 2, just like G of negative 2, is also 3. And f of 3 is 0. This is why we could prove, or we could show, that f of G of 2 is equal and is actually the same thing as f of G of negative 2, which is all equal to 0. Everybody okay with this? So we broke it up into parts. We found f of G of 2, and we even subdivided that further by working out what G of 2 was. And then we did G of negative 2, and then we worked out what f of G of 2 was. And they're all equal to 0. Everybody understand that? Yeah? Okay. Lovely. All right. Next question. Using the elimination method, solve following pair of equations. Equation 1, equation 2. Any suggestions? What are we going to do first? Which is the easiest variable to eliminate first?
Positive 2y, negative 2y.
Yes. So when you're doing simultaneous equations, you always want to look for a matching pair of terms. So I'm going to draw a purple box around these matching pair variables. This is my matching box. For now, I'm not really looking at the signs too much. I'm more concerned with this and this is the same. You're looking for that, especially when we want to do the elimination method. After I've identified which one of the variables have these matching coefficients, I will then examine the signs. I have a positive sign here and a negative sign here. Now the rule is when the signs are the same, then subtract the equations. And when the signs are different, we're gonna add the equations. This is an important part. So the two steps when you're doing simultaneous equation. One, we're looking for a pair of identical coefficients. If you find that something too confusing, identical terms. What I mean by that? 2y, 2y. If I had 4x, 4x, right? 10y, 10y. They must be the same. We're just talking about this for now. The numbers, the coefficients. After we identify that, the next thing we're going to look at are the signs on these terms. And you're asking yourself this question. Is it the same or is it different? If it's the same, then we're going to subtract the equations. If it's different, we're going to add. So in this particular question, do we have same or different?
Different.
Different. So that means that we have to add the equations. Right? So I'm going to say equation 1 add equation 2. Right? Because we identify this as the first and this as the second equation. Now look at this, right? This is a slightly different way to probably what you might have done in school. But I think it's easier because it will help prevent errors with signs. I'm going to look at each one of these separately. So what I mean by that? Let's write it like this. We're going to add, right? Adding equations. So this adding together, this adding together, and this adding together. Everybody agree with that? Now look at how I'm going to write it now. I am going to write, instead of drawing a line, which some people do, I am going to work out each box separately. So 3x plus x, right? This plus coming from out here, plus 2y, this plus 2y, plus negative 2y, and I'll put this in our bracket. And then 5 plus 3, put that in our bracket. Work out each one separately. So 3x plus x will give me 4x. On this side, plus 2y minus 2y. I'm keeping it in the bracket for now. 5 plus 3 will give me 8. This is going to give me 4x. 2y minus 2y will give me 0. 4x is equal to 8 because 4x plus 0 is 4x. X is going to be 8 divided by 4. Because I need to move this across here in order to work out what x is. X is going to be 2. Now, we know x is equal to 2. Then, if we take one of these equations, like say we take 3x plus 2y is equal to 5. And you can take any one really, yeah? Any one would work. Doesn't matter which one you take. We could remove or we could replace this x with a 2 because we know x is 2 now. We don't need to continue to be in the unknown. 3 by 2 will give me 6. And then when I move the 6 across the equal sign, I am going to get -1. And y is going to be -1 over 2.5. So my answers is going to be x is equal to 2 and y is equal to -0.5. So everybody right to that? Yeah? So you see everything there, trying to fit all on one screen because I want to give you a question to try and So this one, the thing was different, right? I'm going to give you a question to do for me now. Sorry. We'll do equation 1, equation 2. I want you to solve this one. Remember your rules. Pair the identical terms. Look at the signs. Decide whether you're going to add the two equations or subtract the two equations. Same sign subtract, different signs add. Right? Giving you a little head start here by identifying terms that I think you should look at. And you're going to follow the same set of procedures and you're going to work this out for me. All right? All right, so this is what your answer should look like. All right, the signs are the same, so we subtracting the equations. All right, when we subtract the equations, the minus, this minus here, this is the most important takeaway. This minus and this minus here would result in a plus. And that's how we're going to eliminate these two, because 5y take away, y going to give me the 0 here. That's why 1. So that you remain with the minus x, and this on this side, so you can actually solve. Now, important to note, the minus x is equal to -4. To get x, what we're really doing is moving this -1 across on both sides. Or you could think of it as you're dividing throughout by -1. Because if I divide -x by -1, I would get x. Yeah? So this x works out to be 4. After I move this over on this side here, -4 over -1 is going to give me x is equal to 4. Once we find out that x is equal to 4, we are then putting 4 inside of any one of these equations. This one or this one. Doesn't matter. I just use the one that my eyes land on first. So 4 by 4 is 16. Minus 5y is equal to 1. Carry 16 across. We get 1 minus 16 is -15. Divide throughout by -5. We get y is equal to 3. Yeah? Everybody right to that? Yeah? Okay. So we have one more that I want to look at. We're switching it up a bit again. Color statistics. The table below shows the distribution of marks on a test for a group of 70 students. This is an important piece of information here. The total sample size is 70 students. The whole frequency column adding up, or the total frequency, if we add up all of these numbers here, the total is 70, right? Because there's 70 students. Now we need to complete the table, right? There's a column called the cumulative frequency column, which is like a running sum. You pretty much adding as you go from row to row to row. So we start at 2. Obviously, it would have been 0 for the anybody who get below 1. 1 to 10 had 2 students. 11 to 20 have 5. 5 and 2 is what giving us the 7 here. Right? So 2 plus 5 giving us 7. 7 plus 9 is giving us 16. 16 and 14 is going to give me how much? 30. 30 and 16 is going to give me 46. 46 and 12 will give me 58. 58 and 8 is going to give me 66. And 66 and 4 is giving me the 70. Everybody understand how to compute a cumulative frequency column? This is what we call a cumulative frequency table. And the type of data we have here is called group data. Anybody can tell me why it's called group data? What is given group data? Anybody know why?
Information is given.
Yes, the information given is in groups. We actually group in 1 to 10 people who got marks between 1 to 10, people who got marks between 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80. There's a special name for these groups. It starts with C. Anybody know what's the name?
Part 5.
Classes or class, right? So these are different class. Now in each class, let's take, for example, the class or the group 31 to 40. This lower value is called our lower class limit, right? This is what defines the class. And this is called our upper class limit. Yeah? Everybody understand that? Now, in order to determine which marks would fit in a particular class, what if somebody got the mark of 40 40.2? Would this still belong in the class 31 to 40?
Yeah.
Yes, it would. And how do we know that? Because in each class, there's something called boundaries. Class boundaries to help us deal with values like this, right? So class boundaries work like this. We have a lower class boundary and we have an upper class boundary. The lower class boundary is always 0.5 less than the lower class limit. So the lower class boundary for this class is actually 30.5. And if the mark is X, X has to be greater than or equal to 30.5. The upper class boundary, we add 0.5 to it, and we get 40.5. But X has to be less than 40.5. So if somebody got a mark of 40.5, they will actually go into the other class, which is 41 to 50. Because the class 41 to 50 actually begins from 41.5 and ends at 50.49. Because when we go to 50.5, we go into the other class. Everybody understand how that works? Now, this is just general knowledge or training here as we looking at the question, right? Everybody okay with that? Right. Now, we could use these boundaries to determine something called the class width. The class width is basically what is the spread of values? How many values you're going to have in each class? So if I take this one, for example, and I take the upper class boundary, and I subtract from it the lower class boundary, abbreviating here now. 50.5 minus 41.5. What answer am I going to get? Check it and see.
9.
9. All right. So the class width is, sorry, I have the wrong thing here. This is not 41. It's supposed to be 40.5. My bad. Right, check it back again then. You should get 10. Yeah? Right. Why I needed to make that change? Your lower class boundary is always minus 0.5 and this is plus 0.5. If I take away 0.5 from 41, I'll get 40.5. Yeah, everybody understand that? Yeah? Okay, good. Now let's talk about part B of the question. Using a scale of 1 centimeter to represent 5 marks on the horizontal axis and 1 centimeter to represent 5 students on the vertical axis, draw the cumulative frequency curve for the scores. Right? Now, 1 sec. So we're doing 1 centimeter to represent 1 mark on the horizontal axis, 1 centimeter to represent 5 marks on the horizontal axis. So let's get this a little bigger. And if we look at our marks going from 1 all the way up to 80, right? So 1 centimeter, every 1 centimeter is 5 marks. So if I start from here, zero. Every 1 centimeter is 5 marks. 5, 10, 15, 20, 25. X-axis, make sure and label the axis. And this is marks. Everybody agree with that? 1 centimeter to represent 5 marks on our horizontal axis. And on our vertical axis, we're doing 1 centimeter to represent 5 students. So if we make this a little bigger, and we start here, change the color. We're going up here, 5, 10, 15, 20, 25. There's 70 students, right? Everybody with me so far? It's up there, right? It's a y-axis here. And then let's go put in our scale. A scale, 1 centimeter represents 5 marks on x-axis. 5 students on the y-axis. Right. Now let's talk about plotting this curve, this cumulative frequency curve. When we plot in a cumulative frequency curve, we need to plot either we use the upper class boundary and the cumulative frequency, or we could use the upper class limit and the cumulative frequency. All right. I am going to use, for the sake of simplicity, our upper limit, like this, and our cumulative frequency. Follow? So 10 is going to go. This is marks, right? 10 marks. So looking for the 10 on my marks axis. 10 and 2. Watch, we have 5 tiny blocks here. So every block is 1. So 2 is going to be right here. See that? Everybody can see that clearly? Right, I'm going to do the other one now. Watch, 20 and 7. So this is 20 here, and I'm going up to 7. This is 5, 6, 7. Then we're going to do 30. You see what 30 line up with. 30 and 16. So this is the line 30 here. 15, 16. See that? Then we go into 40 and 30. 40 here, and I'm going up to 30 up here. Then we're doing 50 and 46. Will be right here. Right? 40, 45, 50. And this is 46 here. Then we're doing 60 and 58. So 60, that's this line here. And we're going up to 58. This is 60. So this is 59. This is 58 here. $70 and 66. This is 70 here, and we're going up to 66, which is right here. And the last one, obviously, had to add n at 70, right? Which is going to be here. Seen it? Now, the cumulative frequency curve is always a S-type looking curve. So it would look like start at 0 and come up like this. Yeah, that's the best I could do it. Probably I shouldn't have done. Yeah, something like that. You probably draw a better curve on paper than I would on the screen. Right, and that's what our cumulative frequency curve looks like. Now let's look at the last 2 questions. What assumption have you made in drawing your curve through the point 0, 0? Right, so that would have been a class, right, that students receiving a mark of less than 1 is 0. That's the assumption. Nobody get a mark less than 1. The pass mark for the test was 47. Use your graph to determine the number of students who placed this test. Now, this part is actually the easiest part of the entire question. You go to your graph, you look for marks, and then you look for 47. This is 45, so 6 and 47 here. And we draw a line going up. Obviously, you'll be doing this with your ruler, right? And then you're going across. So roughly we're talking about 44 students got a mark of 47 and above. Yeah? What is the probability that a student chosen at random had a mark less than or equal to 30? So if we go and look at the mark 30, draw a line going up to our cumulative frequency curve, and then one coming across. We're looking at about 16 students. 16 out of 70. So probability is going to be the successful event over the total number of events. So the total sample size is 70. The total number of students that would have a mark that is less than or equal to 30 is 16. And this is going to be our answer for the probability that somebody had a mark that is less than or equal to 30. Right? We could probably use X to talk about the mark, because our observation is usually in terms of X. Yeah, we okay with that?